All right, Chem people, welcome to our second week of full school here. We are going to be doing some videos again this week. So, for my Chem people, if you guys want to find the notes, go to chapter 1. For me, it's the last things. I just uploaded it to Schoology. Click on classification of matter notes. It'll download. If you want to mark it up, click the box in the upper right hand corner, click mark up, and then we're ready to go. Alright, so without further ado, I don't really have any announcements. My goal is, assuming that we are watching this on Tuesday, which is tomorrow for me, most of your grades from last week should be in by that point. I'm going to finish up this video and then go in to go grade those. So that way you guys should have all of your grades by the time you get to class tomorrow. If you have any questions about that, make sure you guys see me. I'm sure it's a similar situation for Mrs. McLeod and her students. Here we go. Today's learning targets. I can define and correctly use the vocabulary words for this unit. I can classify matter as either a pure substance or a mixture. Okay. So one thing before we even get into it here, just so we're all on the same page. Pure substance. There's two types basically, element and compound. And then mixtures. There's two types. There's a homogeneous and then hetero. Okay, so homogeneous and heterogeneous mixtures. So just so you're aware, if you say it's a mixture, you can always be more specific. You can call it a homogeneous mixture, or you can call it a heterogeneous mixture. If you say something is a pure substance, that's awesome. We can always do a little bit better. We can usually call it an element or a compound. Okay, so let's move on here. Oop. There we go. So two categories of matter. Mixture is the first one we're going to talk about. All right, so this is number 1. Okay, so mixture is two or more substances that aren't chemically combined. Okay, and we'll have examples here in just a minute. The two types, as I just said, are homogeneous and heterogeneous. Okay, and I'll give you the exacts of those on the next slide. But mixtures are two substances that aren't chemically combined. A pure substance is basically the exact opposite. Okay, so this is going to be a substance So it's going to be a substance that has definite and constant composition. Definite and constant composition and distinct chemical properties. Okay, some examples of pure substances would be things like elements. Okay, something like hydrogen or helium. Okay, so elements, or things like compounds. Okay, something like carbon monoxide or carbon dioxide would be a pure substance because it is chemically combined. Okay, so two things: a mixture and a substance. For types of mixtures, we have two mixtures. The first one's a homogeneous mixture. Those of us that are familiar with this prefix homo, okay, it does mean same or one. All right, so the big thing with a homogeneous mixture is that it does have like that kind of same or one idea behind it. So we're going to call it a solid liquid, or gas. So a solid, liquid, or gas that has the same components throughout. Okay? So a solid, liquid, or gas that has the same components throughout. A heterogeneous mixture is quite the opposite. All right, a heterogeneous, hetero meaning many. In this case, it's going to think of it as is more separated, okay? Something that you can see both of the substances, okay? So a heterogeneous would be a solid, liquid, or gas. A solid, liquid, or gas that does not have uniformity throughout. Okay, so for a homogeneous mixture, you guys can think of things like mixing, like if anybody ever does like Kool-Aid packets where they pick and put Kool-Aid and then mix it into your water, okay? Those are not chemically combined, right? You're just mixing it in there, but it does look the same and it does look uniform throughout. So that would be something that's homogeneous. Something that's heterogeneous is something that's not the same and not uniform throughout, okay? So the most common example we see a lot is like salad, okay? You have your lettuce, tomatoes, onions, all of those things in there. It's mixed together, but it's not uniform when you look at it, okay? Types of pure substances. The first thing is an element. Element is something that I'm sure most of us have, or I'm sorry, most of us are familiar with, but it's something that we might be new to, something that is a little bit new to chemistry, okay? The elements are probably something that you talked about briefly maybe in biology with things like carbon, excuse me, things like the carbon footprint or maybe something like that in biology. But here in chemistry, we're obviously going to dive further into that. So let's start off with that definition of an element, something that we are going to be talking about the entire year, okay? So elements are chemical substances that can't be broken down further. Okay, so chemical substances that can't be broken down further. One example, I just mentioned it, is carbon. Another could be something like helium. Okay, carbon and helium are two examples there. Elements are a little bit different than compounds. Compounds are, once again, substances that, okay, so they're chemical substances that consist of two or more differently chemically bonded elements. Okay, so substances that consist of two or more chemically bonded elements. Okay. When you think of compounds, you can think of things like carbon dioxide. That's probably one you're all familiar with. Another one would be something like H2O, water. Okay, two things in the world around you that you've heard of that you're probably very familiar with. Both of those are compounds, okay? An element is just carbon, just helium. It's that pure substance all by itself. A compound is two of those combined, basically. But they're combined chemically, so they are still considered pure, if that makes sense. Okay? The law of definite proportions. This just states that every compound contains constant proportions. So, let me write that in here. Every compound contains constant constant proportions. And what that really means is that if we look at something like carbon dioxide or carbon monoxide, the ratio of carbon to oxygen is going to be the same in all of them, okay? If that makes sense. One sample of carbon dioxide isn't going to have more carbon than another sample of carbon dioxide. They're both carbon dioxide, okay? They both have the same amount of carbon and the same amount of oxygen, okay? The law of multiple proportions is pretty similar. Let me write this in here. The law of multiple proportions states that compounds will form in defined ratios. Okay. Specifically for the law of multiple proportions, think of things like we were talking before about carbon dioxide. So if I think of carbon dioxide, the chemical formula is CO2, right? Notice that the C here, the carbon in the CO2, does not have a number down here, right? I'm going to switch colors for a second. Okay, the CO2 does not have a number right there, all right? There's an understood 1 right there. And here for this O, this 2, that's basically telling me that for every, the ratio of oxygen to carbon is 2 to 1, okay? So if I get samples of carbon dioxide, there's going to be twice as much oxygen as there is carbon atoms in those in that sample, okay? If that makes sense. That's something that we'll kind of delve more into with labs and investigations throughout the year. But it's something that we want to introduce you guys to here as we kind of get working towards the periodic table and thinking in a more chemical mindset. Okay? Switch back to blue. Let's see if I can get this thing out of the way. Perfect. Nope. How do I get this thing down? Go down. Auto minimize. There we go. Perfect. Okay, so now let's go ahead and put this to practice. So this is something that we will probably have you guys do some sort of warm-up question throughout the week, but it's something that's very important. This is kind of like the general basis knowledge. We're going to go into way further detail at different points in the year about elements, about pure substances and mixtures. But in order for you guys to kind of have that background, in order for you guys to go into that detail, you have to be able to understand it now. So I'm going to do, let's say, the first 4 here. I'll do the first 5. I'll do the first 5 for you guys, and then you guys can kind of finish up the rest of them on your own. And if you guys have questions about them, you guys can obviously ask Mrs. McLeod or myself. That way you guys kind of get to see us do some, and then you guys can try a couple of them on your own. Okay? All right, so first one, chlorine. Chlorine is an element, okay? But this particular, the way they have this set up is that it is bonded to itself. So since it is that, it is a pure substance. Okay, it's not elemental chlorine. If it was just elemental chlorine, it would not have this 2 down here at the bottom. Okay, this is actually a compound because it is bonded to itself. Okay, so elemental chlorine would just be listed as Cl. This is Cl2. It is listed. I'm sorry, since it is listed like that, it would be chlorine bonded to chlorine. We'll call that a compound. Down here, water, H2O, is a pure substance once again. All right, for water, H2O, that is absolutely a compound. All right, that's because we have obviously the oxygen and the hydrogens bonding together. Number 3 is soil. Okay, soil is a mixture. Okay, I am going to call it a heterogeneous mixture. The reason being is that I feel you could separate the different components of soil out and go through them if you want. Whereas we were talking about like that earlier example where you kind of poured a Kool-Aid packet into your water, you couldn't necessarily separate that right away. You would have to let it settle and settle out. The next one is sugar water. Okay, you guys see the C6H12O6, that's the sugar, and then obviously the water is H2O. This one's kind of a fun one. So sugar itself, the C6H12O6 is a pure substance, okay, and the H2O itself is a pure substance, but combining them actually together is going to be a mixture. Okay, because they are not chemically combined, okay? The sugar is chemically combined, and water is chemically combined. But if you combine them together, you put sugar into water, okay, that is not a chemical combination, okay? The sugar is simply mixing into the water. All right, and if you mix the sugar into the water, it would disappear, which would make it a homogeneous mixture. Okay. So that kind of concludes how far I'm going to go with you guys today. There are a couple examples still left there. I'm going to leave those to you guys to kind of get some more practice for yourselves if you would like. Obviously, if you guys have questions, we should be up on Zoom right now if you're an at-home person. So if you have a question, just pop your head in, all right? And then I go ahead and ask us a question, okay? Outside of that, thank you guys for watching the video, and let me know if you need anything.